So again, picking up the sketch of this little schematic of a grabber I have here is there was a part here, so this one is fixed. The other two, the angle is determined and the size, and have like a sketch of another plate here. This plate, notice, is I have those two top points the same. This is at 25 degrees. So this one is, this sketch is modeling a plate that would, as if we were on the other side of the roof. Okay, now suppose, well, you can see that what I have here is if I have the pivots on these two positions here, right, and then it goes from here to here, perpendicular bisectors, there's that pivot, right? And for the top part, it goes from here to here, and then from there to there. And so this one actually, if I stretched it out, so this would be the intersection of those two. Nope, I take that back. I'm sorry. This was the bisector for the lower one. So we have the top is here, and then top to top is here. So this point it would be the pivot point to get to these three positions. Okay. Now, suppose I did this so that I wanted like the front edge all lined up approximately. So if I move this one over like that, and if I move this one over about like this, okay, and I said that in one position, in other words, with the robot sitting in one position, I want to be able to move to this position, then to here, and then to here. Well, where would the pivot points be? So the lower pivot point, that corner goes from here and then up to here. And so that one, you can see, is right here. Right, so that's not too bad. But what about the top one? So that corner, the top corner goes from here to here. There's the perpendicular bisector. Then the corner goes from here to here. Well, those are diverging, so it actually would be, I'd have to get this on the other side, right, and then the same thing with this one here. Okay, so now you can see that, and if I move this a little bit further over, okay, anyways, you can see that the pivot point, that's actually the intersection right there. To get, if the robot was just in one stationary position, to get from here to here to here, one pivot point would be right there. The other one would be way over here. So obviously that's not practical. So that means that, you know, to get these in, for these to all be in the same position relative to the robot base, it's not practical. But because we can drive under the roof, we have a degree of freedom in terms of when we're trying to put this one up or this one up, you know, we can be in different locations left to right. So you might say, you know, in other words, we've talked about a lot of things, Grashof, non-Grashof, inversions, all that stuff. But how do you actually do the design? So in this case, there's no clear optimal position to put the pivot. So what kind of things would you want to consider? Well, I mean, it's better to have shorter links rather than longer links, right? It's less weight, it's less material, and you want to not have really high torque requirements. You want to, your transmission angle, remember we talked about that, transmission angle, you don't want it to be too low. So basically what you can do in this case is you have flexibility in terms of where the robot is left to right. So you can just move these around and see now that that intersection is back over here. So I'm just going to try and move that point back over here so you can see where it comes across. Same thing with this one up here. Right, so here's one intersection, here's another intersection. So this is 2 inches at off the ground, and I'm going to have to stop here and pick up from the next video.